surface area, and volume of a sphere. Our last thing of the entire semester. Nothing too crazy, but unfortunately, I will be honest with you, it's like the last thing that we have to cover, and it doesn't really relate to anything else. I mean, it kind of does, but unfortunately, we got some memorization to do. Sorry. If you'd like, there are some warm-ups here for some previous volume calculations you're welcome to do. It might be good to just practice right now before we get into something else. Can you find the volume of a rectangular pyramid, of a regular triangular pyramid, of a cone? 2 cones? Can you do that? If you want, you can pause the video when the bell's going off in the background. And now that you've had time to pause, here are some answers. Curious if you got them. Anyway, today, so we're talking about spheres, 3-dimensional circles. Nothing overly complicated about them. Truth be told, in the grand scheme of things, we really only talk about the radius as like the big thing, which means the diameter can also come into play. But that isn't to say we can't do other things with spheres. There's this thing called a great circle, which is the largest possible circle that fits inside of a sphere. You can think of it as like an equator if you really want to. The circle that divides the sphere exactly into half, that's the great circle. And if you did divide a sphere into half, it would create what's called a hemisphere. So half a sphere is a hemisphere. But like in the grand scheme of things, the radius is what we're going to be paying attention to a lot. And the radius goes from the center to any spot on the sphere. Kind of like you would expect on a circle, or really anything else for that matter, I suppose. So what are we doing today? Well, yesterday, what we did is we took some time and we tried to define how to find the volume of a sphere. Now, there's plenty of ways to do it. This is one particularly interesting way where it uses Cavalari's principle. Like you take a bunch of slices of a hemisphere, and when you stack those slices together on top of one another inside of a cylinder, a cone is formed. Kind of interesting. And if you work backwards, you'd actually find out that with your hemisphere, it would find out that the hemisphere has a volume of 2/3 pi r cubed, which means if you doubled it, that's 4/3 pi r cubed. Makes sense. But we didn't really do that. What did we do? Well, yesterday, you'll recall, we realized that the volume of a cone plus a sphere was exactly the same as the volume of a cylinder. So that means for us, let's see, oopsie. All right, so we have volume of cylinder equaled, let me see if we can see, volume of my cylinder equaled the volume of the sphere plus the volume of the cone. So if we're going to find the volume of the sphere, let's just move the volume of the cone over. Let's see, volume cylinder minus now volume cone, because I'm moving it over, and I'm solving for the volume of a sphere. I know both how to calculate the volume of a cylinder and the volume of a cone. The volume of the cylinder is the area of the base times the altitude. I'm going to subtract the volume of a cone, which I know, that's 1/3 the area of the base times the altitude. And specifically yesterday, we recognized that our cylinder, our sphere, and our cone all had the exact same radius and the exact same height, which meant if you had a sphere, which is very poorly drawn like that, it's not a good sphere, sorry. We actually tried to relate it to the actual height. And if we knew all of them had the same radius, well, how does the radius relate to the height? Well, it's exactly half. Or 2 radii equal 1 h. So, knowing that h equals 2r, if I go here, let's see, area of base times height minus 1/3 of the area of the base times height. Well, 1 minus 1/3 is 2/3. And height is 2 r's. Ooh. 2 times 2 is 4. 4/3 area of the base times r. And wait a minute. The area of the base, that's a circle. Pi r squared. R and R sorry, r and r squared is r cubed. Four thirds pi r cubed. A little bit of a long-winded way to get about it, but that was all we were asking from me yesterday. I took every single step to do it there, but that was yesterday. That's how we did. Oh, the area of a sphere is 4/3 pi r cubed. And quite frankly, this is all I'm gonna this is the big thing you gotta know, just to be honest with you. And the good part about it is, much like circles, there's really only two ways I can formulate questions about this. I could either just give you a radius or something similar to that and just say, hey, plug it in. So like, find the volume of that sphere. Cool. Volume of a sphere is 4/3 pi r cubed. Let me plug in the radius. Oh, be careful. That's not the radius over there. That's the diameter. So I got to take 12 and plug it into that. So I plug 12, I cubed 12, multiply 12 cubed times 4/3. I'm asking to leave you in terms of pi, which I will probably do most of the time, but be advised you can do decimals. You're very able to do that. And you just plug in 12 into our equation. Like, that's calculator, calculator, calculator. Oh, look, I got 2,304 pi inches cubed. Like, it's... But you can't do that unless you know 4/3 pi r cubed is the volume of a sphere. So that's just the thing right there. So that's one. That's the easy thing. The other thing I can do is I can say, tell me the radius, which means I'll give you the volume. Now, you still utilize the fact that the volume of a sphere is 4/3 pi r cubed. It's just, instead of plugging in r, you're plugging in what the volume is, which we know. So for volume, I'm going to put 36 pi in that spot. Fortunately, I notice the pi's will cancel on both sides. That's great. And then when the pi's cancel and divide both sides by 4/3, aha! R cubed is equal to 27,000. This is where you need to recognize you're probably going to have to use your calculator to find the third root of something. Because I'm going to guess you don't know what the third root of 27,000 is off the top of your head. And neither do I. So you better make sure you know how to use your any root button, which is the thing that looks like that with the little, probably normally has like a little X there or something to that effect. So you better know how to use that, because otherwise you're probably not going to know that the third root of 27,000 is 30. So you got to do that. But again, in the grand scheme of things, like, either plug in the radius or solve for the radius. Work backwards. That's really all I can ask. Like, there's not too much I could do. Well, I mean, I guess I could put a hemisphere out there. Oops, sorry. Oh, yeah, this asks for the diameter. Double that. Whatever. I could ask for a hemisphere and have you memorize the volume of a hemisphere. But most people don't do that. Most people just find the volume of a sphere with the same radius, and then when you're done, divide by 2. That's what most people do. I do. I'm 4/3 pi r cubed, cube 15 times 4/3. Leave in terms of pi. And then divide by 2. But yes, there is that you could. By the way, the volume of a hemisphere is 2/3 pi r cubed, because 4/3 divided by 2. 4 divided by 2 is 2. 2/3. Anyway, you're still just plugging in. Nothing over the top. Try one. Solve for the radius. Pause the video. See what you get. How'd you do? 4/3 pi r cubed equals the volume, and that's the volume. So I start with the equation and plug in your volume, which I gave you. Pi's cancel. Yay. Divide both sides by 4/3. And take a cube root. You should have gotten 12, at least by now. Yeah. Oh, yeah. Well, hold on. This is the time where we digest and just go like, cool. I kind of have to know the volume of a sphere is 4/3 pi r cubed. I can't do anything without that. Because again, all I'm going to make you do is either plug in or solve for r, which means I give you the volume. And if I'm nice, pi's cancel. This would be a good time to bring up something old. So, just as a reminder, this doesn't go away. We're dealing with volume. We're dealing with surface area. Hey, if I change that radius by a factor of 3/4, how does the overall volume change? Now you could find the volume of the new, and you could find the volume of the old, and you could compare them. But you shouldn't have to. Because while those are just plug-in problems, please let's remember how scale factors affect every single respective dimension. That's what I'm going for. That's a word. There we go. An individual like length, like the radius, that would be multiplied times 3/4. The circumference of the great circle, that would be multiplied times 3/4. But like when we talk about area, those aren't affected by your scale factor because area is a two-dimensional measure. So you're applying 3/4 twice. So you'd have to affect it by the scale factor squared. And volume, that's 3 dimensions. Length, width, height. You're applying that scale factor 3 times. So we should know that it would be changing by not 3/4, not 3/4 squared, but 3/4 cubed. 3 dimensions. That's why the units are cubed, by the way, because they're cubic. So, whenever you're dealing with volume, scale factor cubed. Area, scale factor squared. Everything else, normal scale factor. That's how we normally talk about things anyway, but we don't realize how it affects other dimensions. So, if I had balls of different diameters, remember the other way I could have you do these things is like find how much bigger one is than the other. So this is like developing the scale factor. So the scale factor relates the 34 to the 22. So, but that's not how we would find the volumes. We would compare them. 34 to 22 is the scale factor. That's how much bigger it is. But 34 divided by 22, see, 34 divided by 22 is not 3.7, because that's just how we compare things. The direct scale factor, if I cube that, oh, that looks right, 3.7. 3.7. So if we find out, we see our scale factor turns out to be 34 to 22, cube that. That's how the volumes are different. We're applying that value cubed. Okay. Same idea. The diameter of a hummingbird eye is 0.6 centimeters. How many times as great as the volume of human eyeball? Well, I mean, assuming we knew what they were, we would compare 2.5 to 0.6 and take that number and cube it. So scale factors, still a thing. Anyway. Also surface area. Surface area was the other thing we calculated yesterday. Now, again, there are plenty of ways to do it. This is a really unique one. When you just take the number of pyramids that are associated with it, and when you do the base times the height, and you figure them all out, you'd get like it's about like it comes out to be about 4 pi r squared. But that's not what we did yesterday. Yesterday we recognized that we found out that the surface area of a sphere turned out to be the same as the lateral area of a cylinder, and we know how to find the lateral area of a cylinder. That's perimeter of the base times the height. But remember, height was 2 r's. And the perimeter is a circle. So I've got 2 pi r times 2r. 2 times 2 is 4. Pi, r and r is r squared. 4 pi r squared. That's all we did yesterday. Nothing too nuts. And yes, just like with volume, you just kind of have to know this one. Just going to be honest with you. Because just like with volume, there's only really 2 things I can do to ask you. I could like say, hey, here's the radius, plug something in. Or I suppose in this case, diameter like I did last time. Okay, take 76 divided by 2, 38, and plug it into 4 pi r squared. Surface area, radius 36, 8, excuse me, go. Like, not tough. So you're either plugging something in, or you're working backwards and solving for r. I guess I'm getting a little frisky. I guess I could say use that r then after you're done, which is what this problem does, actually. I give you the surface area of 324 pi. So we would say, okay, I know surface area is equal to 4 pi r squared. Cool. I'm being told the surface area is 324 pi, so I'll plug that in. Pi's cancel, divide by 4, solve for r. 324 divided by 4 is 81. Square root of that is 9. Cool, I found the radius. I worked backwards and found the radius. Just like volume, like exact same thing. Except I'm not taking the cube root, I'm taking the square root, because r is squared in this case. Now I'm like, oh, well, tell me the volume. Use r. So, again, it's still just, I'm either asking you to plug something in or solve for r. That's really all it is. Solve for r, work backwards. Same thing. Now here I'm asking you to apply it. Plug it into the 4/3 pi r cubed, which again you have to know. There's like no real easy way around that one. I'm sorry. Try one. Let's see if you can use the great circle. Pause the video and let me know. Did you recognize it's just a circle? Yeah. Chapter 10 problem? Maybe even less than that. It's probably less. That's probably a middle school problem. I give you the area is 49 pi. And I know how to find the area of a circle. It's pi r squared. So you're going to work backwards and solve for r, like we've been doing. It's a circle in this case. So this wasn't even something you kind of like really had to be on the up and up about. I mean, well, you did, but like it wasn't like new. Pi's cancel. Square root of 49. By the way, when you see 49, like, I've said this multiple times. You see 49. 49 only exists for one purpose and one purpose only, to be 7 squared. You see 49, 7's probably going to be somewhere around there. It turns out to be the radius in this case. But come on! Only purpose. Anyway, once you solve for r, I've worked backwards to solve for r. Now, surface area. Oh, thank goodness I know that the surface area of a sphere is 4 pi r squared. Plug 7 in for r. 4 times 49 is 196. Easy one. Pause. This was easy one. Like this one you want, right? You did take 50 and divide by 2, though. Yeah? Because that's the diameter, not the radius. So 4 pi r squared, r is 25. So square 25, 625. Multiply times 4, and you get 2,500 pi. See? Not bad at all. Oh, yeah, but by the way, changing dimensions. I'm dividing the radius of the sphere by 3. I wonder what I should divide the surface area by. Oh, yeah. Surface area. Area. Scale factor. Squared. So, yes, you could find both surface areas, I suppose. But you should know. Oh, scale factor 3. Area is affected by 3 squared. 9. And, of course, volumes. It's volume. Scale factor cubed. You know how I know that? Because we did this one already. Anyway, that's really it. We just got to know our equations. Surface area is 4 pi r squared. Volume is 4/3 pi r cubed. And there's only 2 ways to do anything. Plug in r, work backwards and solve for r. And that's kind of it. Pretty nice, easy way to wrap things up if you ask me. Got any questions? You know where to find me. Be good, y'all.